Good afternoon, students. That today our topic is next topic will be potential difference and potential difference. We were just discussing the lesson electricity, the topic potential and potential difference. Now further we will continue to that. Next topic will be electric circuit and the some of the components and Ohm's law. And we will also discuss some of the NCERT numericals today also. Now students, the next is a electric circuit and symbols of electrical components. Electric circuit and the symbols of the electrical components. Now student, electrical circuit, it is a closed path. It is a closed path through which the electricity can flow. It's a closed path which allows the electric current to pass through. That's called the closed circuit. Now student, open circuit is that circuit which does not allow the electric current to pass through. So we have discussed closed circuit and open circuit. Now students, closed circuit and open circuit, this closed and open circuit, the function is done by the switch or plug or key, plug or switch. The function to make the circuit close or open, this is the function of the switch, plug or the key. Is it clear, student? Now the next, here I draw the diagram of the electric circuit and we'll discuss some of the electrical components what are used in that electric circuit. Here is a ammeter, students. Now this circuit is completed. Now current will flow from this direction, from the positive terminal to the negative terminal. Now student, here in this electrical circuit, this is the electric circuit. Here is a bulb. This is ammeter. This is key or plug or switch. This is the battery. Now student, the direction I have shown from this side, it is from the positive to the negative. Now student, this is the source of electricity, that's battery. Bulb, it will give the output, and ammeter, it will use to measure the electric current. Here is the key I have shown, it is the now key is in the close. Now student, this key will allow the circuit to close to open. When this key is closed, means this is dot, I have shown the black dot. Now this, it means the key is now plugged or the key is closed. Now the current will flow, circuit is closed. Now if it is shown as a black, it means now the circuit is open, it will not allow the current to pass through. Now student, the current which is flowing from the positive terminal to the negative terminal, it is known as the conventional current. It is known as the conventional currents. And inside the circuit, this is outside the circuit current is, I have shown the directions, but inside the circuit also the current flows. The inside the circuit also current flows. So this is called the electronic current. This is called the electronic current, the current which flows from the negative to the positive terminal inside the circuit. This is called electronic current, and the current which flows from positive terminal to the negative terminal outside the circuit, that is called the conventional currents. So two types of current, student. One is a conventional current. Number two, electronic current. The current which flows from the positive terminal to the negative terminal, positive to the negative. That's called the conventional current. Now, electronic current from negative to positive terminal, that is inside the circuit. Is it clear, student? Now we'll discuss the components and symbols of the different components. Before that, there are some of the NCERT questions are given here. That book, that is a page number 200. We'll discuss those questions also. Now, students, already that earlier also that we have discussed these NCERT questions. Now, students, for your symbols of the electrical components, it is given on the page number 203. Now, students, first is a cell. This is a cell. Cell is a device which converts chemical energy into electric energy. Chemical energy into electric energy. And students, this cell is having two terminals. One is a positive terminal, another one is a negative terminal. Positive terminal and negative terminal. And cell is a device which converts chemical energy into electric energy. So first symbol it is given in your book. Is it clear, student? The symbols of cell. That one line, bigger line, it is showing the positive terminal, and this shorter line, it is indicating or it is showing the negative terminal. Cell is having two terminals. One is a positive terminal, another one is a negative terminal. Is it clear, student? Next is a battery. Battery. Now, student, combination of two or more cell. The combination of two or more cell, it is called battery. Here, I draw. Now, student, it is a positive terminal, then negative terminal, then positive and negative, again positive and negative. Student, here I have shown three cells. It is a combination. Here I have shown three cells. It will be two cells also. For example, the potential difference of one cell is a 1.5 volt. Now here three cells are there. It means multiplying the 4.5 volt. Is it clear, students? So it is a battery. Now battery is a combination of two or more cells. That is called battery. This is the symbol of the battery. Is it clear, student? Now third symbol, it is given as a plug or key. Plug or key. Now student, it is given as a plug or the key. Whenever there is no dot is shown, now it is the open key. Open key or open plug. Is it clear, student? Now if I put this means black dot in this. Now this is also symbol of plug or key, but it is closed. Closed key. Means when this circuit will be closed, that time will show that it's a black dot. It's a symbol of the symbol of closed key. Is it clear, student? Now next is a wire joint. So I'll draw these next symbols. Next is a wire joint. Wire joint. Is it clear, student? This is a symbol of wire joint. Now, next is a wire crossing without joining. Here is a student, this already wire is there. Another wire, it is crossing it without joining. That crossing of wire without joining. This is a symbol of the wire, that is joining, it is crossing it. Now next is the students, the electric bulb. This is a symbol of electric bulb. If I want to show the electric bulb, so I'll make this type of the symbols. Is it clear, student? Symbols of electric bulb. Now, student, few more symbols are there. So we'll discuss those symbols also. Here, one symbol is shown as a resistance. The symbol of the resistance is actually it is a resistance, but I will write down this. It's a fixed resistance. Reason, because this resistance, I'll tell you what is the resistance, and first you note down the symbols of the resistance. Because why I have written the bracket, it is fixed because its value is fixed. If I require this component, for example, any of the electrical appliances, for example, it is not working, and just I taken that electrical appliances to the mechanic. Now mechanic says, sir, there is a fault in this, and now one resistance is required to be changed. Now, student, if there is a specification is given on this, say it is 2 ohm. Ohm is the SI unit, or it is a symbol of the SI unit of resistance. Ohm. 2 ohm, it is a fixed value because it cannot be changed. Because if I demand the resistance is required, that specific it is given, it is a 2 ohm. So it is a value is fixed. That's why I written in the bracket. This resistance is fixed. Actually, resistance hai kya? What is the resistance? Resistance means to oppose the flow of current. It is a means I can say the component or the device which opposes the flow of electric current, which opposes the flow of electric current. That is called resistance. Resistance means to resist means to oppose the electrical current, to oppose the flow of electric current. That is called resistance. Is it clear, student? This is a fixed resistance. So now I draw the symbol of variable resistance. Variable resistance, students. Same way, this is a resistance. Here I put one arrow. It is a variable resistance, means the value can be changed. This is called variable resistance. And another name of variable resistance, it is known as the rheostat. Variable resistance. Variable resistance, or it is known as the rheostat. It is known as the rheostat. It is known as the rheostat. Clear, student? The rheostat is the another name of variable resistance. Means this resistance, this resistance can be changed. Means there's some sliders. It's a resistance is there. We can, by sliding it, and we can change the resistance amount of that's the value of the resistance. If I require 2 ohm, I can just make it as a 2 ohm. If I require 3 ohm, I can make it as a 3 ohm. And if I require 1 ohm, that time also I can reduce it to the 1 ohm also. Because this value is not fixed. That's why I have written as a variable resistance. Or another name, that is a technical name, it is known as the rheostat. Technical name, it is a rheostat. Now, student, there are 2 more symbols I am going to explain. One is the ammeter, voltmeter. So already I have discussed when I was explaining the current and the potential difference. There already I told you the current is measured with the help of an ammeter, and potential difference it is measured with the help of a voltmeter. Now I draw both the diagram, that the ammeter and the voltmeter. Now students, ammeter, this is the symbol of the ammeter. Here it is written as A. Now student, it is a plus and minus. This is the ammeter. Ammeter is a device which is used to measure the electric current. Is it clear, student? Ammeter. And already I told you the ammeter is a device which is used to measure the electric current. It is correct. Now, student, ammeter is always connected with the series of electric circuit. Whenever we are putting the ammeter in the electric circuit, that time we'll put in the series. Question again, already I told you the very important question, why the ammeter is always connected in the series of electric circuit. Very important question for your competitive exam, board exam, NTSC, and all the other competitive exams, science, computer, and all. Why the ammeter? It is always connected in the series of electric circuit. The answer is very simple to this. The ammeter is always connected in the series due to its low resistance. Due to its low resistance, it is always connected in the series of electric circuit. Clear, student? Now, ammeter, this is the ammeter. Now, voltmeter. Voltmeter symbol is like this. To measure potential difference. Now, student, voltmeter is a device which is used to measure the potential difference. Potential difference, for example, the cell. The potential difference of a cell is a cell. Positive, negative, it is a 1.5 volt. 1.5 volt is the potential of this cell, single cell. If two cells are there, it is a 3 volt. Now, if we want to measure the potential difference of any of the source of electric energy, let it be cell, let it be battery, then already it is mentioned, but I want to certify that whether it is 1.5 volt, whether it is of 3 volt, and if it is not given, then what is the value of the potential difference of that source of energy. So the device which is used to measure the potential difference, that is called the voltmeter. This is the symbol of the voltmeter. It's the positive terminal, negative terminal, students, and the reading it will be 0, 1, 2, 3, 4, and this also 0, 1, 2, 3, 4. Ampere is the SI unit of current, and the current value of the current is measured with the help of ammeter, and volt is the SI unit of volt is the SI unit of potential difference, and the value is measured with the help of a voltmeter. Now, question very important. Voltmeter is always voltmeter is used to measure the potential difference. This is one question. Now, voltmeter is always connected in the parallel of electric circuit. Now, student, why? Again, very important question. As it is the ammeter, that question is important, very important for this also, either that or this. For current, ammeter. For potential difference, it is a voltmeter. Why voltmeter is connected always in the parallel to the electric circuit? Again, very important question for competitive exams. Now, student, voltmeter is always connected in the parallel of electric circuit due to its high resistance. Very simple answer. Voltmeter is always connected in the parallel of the electric circuit due to its high resistance. Is it clear, student? Now, further we'll continue with the some of the numericals and followed by the Ohm's law. Please, if you want to note down, please you can note down. We'll further continue with the NCERT questions which are given on your page number 203. Now, student, your first question which is given on the page number 203, NCERT questions. Now we are going to discuss first NCERT questions. First question, students, I read it out and here I'll give the solutions to the write the solutions of. The first question is on page number 202. It is given on page number 202. Now, students, first question is name the device that helps to maintain the potential difference across the conductor. Name the device. Only he is asking the device. Name the device that helps to maintain the potential difference. Already you know the answer, student. This question, question number 1, answer. The answer of this question number 1, it is a voltmeter. Is it clear, student? The answer of your question number 1, It is a voltmeter. Voltmeter is a device which is used to measure the potential difference of a conductor across the conductors. Now, question number 2. What is meant by saying the potential difference between 2 points is a 1 volt? What do you mean by 1 volt of potential difference? Question number 2. 1 volt potential difference. What is the definition of 1 volt of potential difference? Now, student, as per the definitions or the formula is potential difference. It is the amount of work done, means V is equal to W by Q. The definition of the potential difference, it is the amount of work done in bringing the unit positive charge from one point to another point. Now, student, for unit positive charge, I can write down the value of Q. Q is the charge. That is a 1 coulomb. I can write down. Now, student, here the work done is the same. It's the 1 joule, because joule is the SI unit of work done. Joule is the SI unit of work done, because work done or energy, if I use the word, that's the energy. Now, energy and work both are in the similar unit. The SI unit of work is joules. I written joules. If when the work done is 1 joule, and the charge 1 coulomb, that time the potential difference is said to be 1 volt. Now, student, 1 volt of potential difference is that potential difference across the conductor when 1 coulomb of charge pass when the work done is 1 joule and the charge is 1 coulomb. That time the potential difference is 1 volt. The answer to your question number 2. I think it is clear. Now, student, question number 3 we'll discuss. Question number 3. Question number 3. Now, student, question number 3 is, how much energy is given to each coulomb of charge passing through the 6-volt battery? First, I write down the question number solutions of question number 3 of your NCERT. Now, student, how much energy is given to each coulomb of charge passing through a 6-volt battery? Now, student, formula is V is equal to W by Q. Now, you have to calculate how much energy, means you have to find out the value of energy. Now, it has given as a 1 coulomb of charge. Each means 1 coulomb. Each means 1 coulomb. Now, the value of the potential difference battery, that it is given as a 6 volt is equal to work done. I can write down energy divided by 1. By cross multiplications, students, by cross multiplications, the work done will be, or the energy value of the energy will be 6 into 1. It is known as the 6 joule. So 6 joule is the answer to your question number 3, students. Is it clear? Please note down. Now, student, we are going to discuss a very, very important topic, Ohm's Law. Very, very important topic, Ohm's Law, students. Now, Ohm's Law, very, very important topic, students. Ohm's Law. What is Ohm's Law? Now, students, that Germany, that one of the, it is a scientist who has given us it is a George Siemens Ohm, who has given this law. George Siemens, that Ohm, he has given the law, that Ohm's Law, what it says. At constant temperature, I write down the statement. First I'll explain, then I write down the statement. At constant temperature, when the potential difference across that conductor, it is directly proportional to the current. What it says. So I write down first, at constant temperature, the potential difference across the conductor is directly proportional to the current passing through the conductor, passing through that conductor. This is the statement of the Ohm's law. The statement of the Ohm's law: at constant temperature, the potential difference across the conductor is directly proportional to the current passing through that conductor. Very simple law, and I'll write down the mathematically what this law says. Now, student, according to the statement that at constant temperature, when temperature remaining constant, clear, student? When temperature remaining constant, now the potential difference across that conductor directly proportional. Here I write down temperature remaining constant. What this is a symbol of the directly proportional. For example, students, I got these two objects, one object, two objects. Now, if both are directly proportional, there are two words I will be using: directly proportional and inversely proportional. Here they are given the directly proportional. Directly proportional means if one quantity it is increasing, if this quantity is increasing, simultaneously this another quantity will also keep on increasing. If this quantity is decreasing, simultaneously this quantity will also be increasing. And the reason that both the quantity are in the direct proportions, means it is increasing, it will also increase, and if it is decreasing, it will decrease. That is a directly proportional. But in inversely proportional, if one quantity it is increasing, that second quantity it should not increase, decrease. They are the inverse proportional. Here, student, V is directly proportional to I, means potential difference is directly proportional to the current passing through that conductor. Now, students, now here it is given as a directly sign of the directly proportional. I have to remove the sign of the directly proportional. For that, I'll put one constant. V is equal to R into I, where R is a constant. Where R is a constant. Is it clear, student? Now, from that equations, V is equal to R into I. Is it clear? V is equal to R into I. Now, student, if I V divided by I is equal to R, it is a constant. What this statement says? The ratio of the potential difference, to the current. I compare the potential difference and the current. The ratio of the potential difference to the current, the value is constant. If this value is constant, it proves the Ohm's law. This is only the Ohm's law, students. If I draw the graph between V and I, now further to that Ohm's law, again I write down it is equal to R constant. Means here it is a potential difference divided by current. The ratio of the potential difference, I write down ratio of potential difference to the current remains constant. This is the extent of, I'm using the word extent. Extent means outcome of Ohm's law. Extent of Ohm's law, the ratio of V and I. The ratio of V and I is Ohm's law. If this ratio remains constant while doing the experiment in the lab, so student, if I take the circuit diagram, circuit is there. So if I take the ratio. First, I will put down the reading of potential difference. Then I take the reading of current with the help of the ammeter. If I divide both the reading, this is the value potential difference, whatever I have noted down. So I'll give the one example to that. Now, student, if I draw the graph between V and I, if I draw the graph between V and I, here it is, student, this is our x-axis, and here it is your y-axis. Generally, for the remembrance, I used to tell to the student how to remember where we can take the V and I. So, student, this is a vertical line. Remember that vertical line, please take V. Here, V potential difference, vertical line along with the vertical line, take the potential difference. Along the horizontal line, you can take the current. And if you will plot the graph, now definitely this graph will be. Take the 4 readings or 5 readings. So when you will plot the graph between V and I, it will be constant, and it proves that Ohm's law. Is it clear, student? Now, I'll take the readings and further I'll discuss with the SI unit of resistance also by using the Ohm's law. Now, students, please note down. Here it is given as a V by I is equal to R. Now, student, the SI unit of potential difference, it is a volt. If the potential difference is 1 volt, it is a 1 volt. Is it clear, student? And the value of the current, it is a 1 ampere. The value of the current is it's a 1 ampere, and the potential difference is 1 volt. Then the resistance is 1 ohm. Is it clear, student? So we have concluded the definitions of the resistance of one. That's a 1 ohm. Ohm is the SI unit of the Ohm is the SI unit of resistance. Ohm is the SI unit of resistance, and 1 ohm is that resistance when 1 volt of potential difference across the conductor when 1 ampere of current pass through that. Means 1 ohm is equal to 1 volt divided by 1 ampere of current. This is the formula, and this is also another. Please note down, students. This is the total explanations of Ohm's law. Now with the numericals,